Hi everyone. So I wanted to show you what's my workflow when trying to create new mechanics. So what do I do? How do I break down things? So let's assume that I want to create a dash mechanic for the cat. So I want to, if the cat is moving and I'm pressing the shift button, I want the cat to dash. So how am I going to do that? So let's go into the cat controller script. Let's close these other things. So I'm gonna create first thing first. I need to create a method for it because I don't want code hanging out around kind of other places like here. So I want to create a method for it. Private void dash. So usually before starting to do the actual code, I want to break down the logical steps as in pseudocode. So what I'm gonna do is I'm gonna start to break down the actual mechanic into logical steps, and I'm gonna put comments in order to kind of say what they do. So first thing first, check if I am moving. If the cat is moving. The first thing is to check if the cat is moving. Now it makes sense. So I'm going to leave some space because then we're going to actually implement logic there. Then I'm going to say, check if I am pressing the dash button, which is something that we are going to assign. Then I want to increase speed for a set amount of time, and then bring speed back to original point, to original value. Okay, after time runs out. Cool. So as you can see, I broke down a big mechanic. Well, it's not super big, but a whole mechanic into more manageable steps. Okay, and all the reasoning on this is like, okay, what's the first thing I need to do? What's the next one? What's the one? I'm trying to basically do logical small steps. So let's do this. So how do we check if the cat is moving? So usually we check with an if statement. So I'm going to say if, and now we say RB. This is not super correct, but I'm going to do an incorrect kind of thing. And then we're going to try to basically see how to fix it. So if we say if rb.velocity.x is greater than 0.1, and we're going to put debug.log to check to say moving. Okay. Cool. So let's see. I'm gonna put it in the update. So we're gonna test it. Dash. Okay. And I want the smart things to do, and the things that I usually do is to basically test every little thing, everything a little bit at a time. So for now, I want to check, does this make sense? Is this actually recording that the cat is moving? So let's test it. I'm going to press save, then go back in Unity. So what I'm expecting to see is that if I go left and right, the cat is moving. So I go to the right. Perfect. It's moving. So let's kill this. I don't care about this. So this was from another video, if maybe you've watched it. But let's go back. So clear. So if I'm going to the right, terrific. Yeah, it's getting like a moving every frame I'm going to the right. I'm gonna press clear. But what if I go to the left? If I go to the left, it does not print the message. Why? Okay, that should be your reasoning. Should be why? Why is it doing that? So why? Okay, so what you should think about, like, oh, if I'm going to the right, it's printing. If I'm going to the left, it is not printing. Okay, so Since we're checking for the velocity, what I'm going to do is like, okay, I'm going to duplicate this. I'm going to check what is this value. The x velocity value, it's equal, plus, is equal to, and I'll leave a space, and then put RB. So we can be able to check what's the value. Okay, so we save, go back. Cool. 4.9. And if I go back. Okay, so why is it not printing? Because I made a mistake. So what is the mistake here? That I'm still checking if this is greater. So what I'm gonna do is instead to do it outside of the if statement. So it should be running anyway, even if I'm going to the left. So cool, equal to 0. And if I go to the back, it's minus 492. Okay, so therefore, if I'm going to the left, the value becomes negative. So how do we fix this? Check if the cat is moving. So the thing that I can do is gonna say, if I'm gonna basically use the mathf kind of library, mathf.absolute. So if the absolute value of this, so the positive value, remember the absolute value is how far is distant from 0. So if the value is greater than 0.1, moving. So let's test if this makes sense. And obviously there are many ways to do this, but you know, moving. So now it's moving if I go in both direction, okay? So this is already how I solved it. Obviously I solved this using this because I knew about this, but there are many ways to do this. You will have to find the one that works for you. So this is the first one. So, okay, then check if I'm pressing the dash button, because basically in reality, things are gonna be here, okay? So then we're gonna say if, not that, if input, because of what is the to press buttons is input dot get key down, and I'm gonna say key code dot left shift. Okay, I'm gonna put another debug.log, and I'm gonna say pressing dash button. Cool. So I'm gonna go back in Unity. I'm gonna test this out. So remember, you need to stop playing, start playing again. So I'm gonna go, boom. Yeah, if I'm moving and press shift. Okay. So cool. So now we're gonna actually, obviously these things are gonna be inside of here, because we want them to happen only if the if statement is true. And a cleanup, I also like always to kind of clean up my method to not make it look too nasty. And also this could have been in one line where I check for this and for if I'm pressing, but I wanted to kind of break it down into to make it easier to read. So how do we do? So I want to increase the speed for a set amount of time. Okay. In general, when I want to use a timer, I'm gonna create an IEnumerator. So a coroutine, because this is what I do when I want to kind of add some time, some weights. I'm gonna say IEnumerator increase speed, and I'm gonna say increase speed for a certain amount of time. Basically this one is gonna be brought into this, because now now the value is the things that we need to do needs to happen in the coroutine, and then we're gonna basically call it here. We're gonna say start coroutine. I'm gonna say increase speed. Okay, so don't worry too much about like the actual code. I'm trying to kind of talk you through why my reasoning in order to potentially kind of show you how I think and how you should think. Okay, so I'm gonna increase the speed. First thing first, I want to save the speed, the original speed. Okay, store original speed. Okay, we need to have something to go back to. So we're gonna say float original speed is equal movement speed. Cool. Then we're gonna increase the speed. We could say increase. Let's break it down. I'm gonna increase the speed first, because this is actually sometimes you need to break down even more. So as you can see here, I had to break it down even more. So increase the speed and say movement speed is equal movement speed times 3. Okay, and then for a set amount of time, so we're gonna say yield return new wait for second. I'm gonna say that the dash is gonna last only 0.3 seconds. Okay, and then we are gonna bring back the speed to the value. We're gonna say after this amount of time, we're gonna say movement speed is equal to original speed. Okay, so and now we're gonna test it and see if it works. So I'm moving up and it get cool. Boom. So as you can see, this is a way to do it. There are other ways to do this. Okay, so what we could do is add force or whatever. There are many ways to do it, because the problem with this is like that if I stop to move after I press dash, it's not gonna stop straight away. Okay, because it's related to basically to the movement speed. What we can do is, instead of basically do this, increase the speed, we could actually gonna say create another one, add force to dash. You can say nope, we're gonna say we're gonna add force to, well, actually we don't even need to make it like into a coroutine. We're gonna say I'm gonna comment this out in order to turn it off. And then we're gonna say add, leave some space, add force to the rigid body to push it. Okay, cool. And we're gonna say RB dot add force. And how does the add force work? I'm gonna take a vector to dot force to add the force. Okay, we're gonna say the basic is gonna say the direction. What's the direction of the direction of the cat? Okay, we're gonna say RB dot velocity times 3. Let's see what that happens. So this is an assumption. We're gonna try to see. Actually, I'm gonna also add force mode 2D dot inputs. So let's see what happens. So I'm testing now. So I would try to think, okay, what's the way to do it? And then I would test it. So if I go here, nothing happens. Okay. What if I say times, I'm actually going to store this into a variable. Okay. I'm going to say serialized field. Private float, and we're gonna call it dash power. Power. Cool. I'm gonna then use this. Dash power. Cool. I'm gonna go back. Dash power, say 100. The good thing about saving into a variable is that we can change it at runtime. Oh, nothing. What if it's let's add the 0. Nothing. Another 0. And then I'm starting to think that maybe this is not working, okay? There's too many zeros, okay? So what I'm gonna do is like, what if I say, I'm forcing it, direction, vector2, dot right, okay? So this is gonna be a vector2 dot right, so it's not gonna work in the sense that it's not gonna push it to the left. But let's see, let's just test what happens. So if I'm going to the right, so a few more. Oh, as nothing is going on. So why? Okay, so we need to find out why. Why is this not working? Okay, so basically this adds 1 to the x and times the dash power. Okay, potentially this is because this velocity here overrides whatever this is. So this is not working. So what I'm gonna do, I feel like, since this is the method that I'm using, probably this is the potential best way to do it. Okay, it's still kind of like not the best, but you know, it kind of works with what we have. So I would skip this, I would delete this and just reinstate this, and then we can just make it a bit tighter. So what we don't want is having magic variables. So what is a magic variable? A magic number, sorry. It's numbers that we just have here. And what do they mean? They mean nothing. So what we can do is like dash power. We can have this to be the dash power. And this one, we need to kind of create maybe another variable for it. I'm gonna duplicate this, dash duration. Okay, I'm gonna call it dash duration. And now these values are stored in variable that we can control and that we can tweak. So if we go back here, I'm gonna go here to 5, dash duration 0.1. Let's see what happens. Boom, boom, boom. Cool, it looks cool. So I'm gonna stop it here, but this is kind of what I wanted to show you on how I would go about creative mechanics. So break it down in little steps, okay, little logical steps. Remember to kind of sometimes those steps will be broken down even further in order to make it work, and break it small, okay? Sometimes mechanics can be hard to implement because you're thinking, oh, how am I going to implement this? Because it sounds so big. But then if you start to break it down into logical steps, then it's easier. And do not shy away from actually try to talk it out loud. There is something called rubber duck debugging that is all about try to talk your reasoning to a rubber duck in order to kind of see if it makes sense. Even though the rubber ducky is not gonna give you any actual feedback, the talking out loud is going to help you out, and it is scientifically proven. And so do not worry about it. You're not gonna be a weird or whatever, but you know, just make it work. Okay. Awesome. I'll talk to you soon, and thank you very much for listening.